Right, here's solutions for quiz 2 for math 251. Basically what we're doing is using the definition of the derivative or the difference quotient to figure out a bunch of stuff. First we want to figure out f prime of 2 using the definition of the derivative. Okay, the way you can figure out f prime of 2 is referring to this formula up here. That's going to be equal to the limit as x approaches 2 of f of x minus f of 2 over x minus 2. And since we know what f of x is, namely it's 2x squared, I can say that this is the limit as x approaches 2 of 2x squared minus, let's see, f of 2, if I change this x into a 2, 2 squared is 4, times 2 is 8. I get 2x squared minus 8 divided by x minus 2. I can't change all the x's to 2's because that would give me 0 over 0. But what I can do is get a little bit clever with my algebra. I can first factor out a 2 from the top, and that'll leave me with x squared minus 4, which I can write as x plus 2 times x minus 2. And although I can't cancel out the x minus 2's without this limit here, with the limit here I can cancel them out because the limit is not concerned with what value this function takes on at that exact point. What I'm trying to say is cancel out these x minus 2's right here, and we get that this is equal to the limit as x approaches 2 of 2 times x plus 2. Change all the x's into 2's now, and we get that this is 2 times 4, in other words, 8. All right, now do that again. Just different function and use the difference quotient instead of the definition of the derivative. Okay, fine. Difference quotient tells me that g prime of 3 is going to be equal to the limit as h approaches 0 of f of 3 plus h. Nope, not f, g. Change the name of my function. G of 3 plus h minus g of 3, all divided by h. Well, my function g of x is 1 over x minus 1, so g of 3 plus h, I'd have to change this x into 3 plus h. And if I did that, I get 1 over 3 plus h minus 1 minus 1 over 3 minus 1. And that whole thing is over h, and I forgot to write limit in here. This is the limit as h approaches 0. Okay, then you can simplify this a little bit. 3 minus 1 is 2, so this is 1 over, this is the limit as h approaches 0 of 1 over 2 plus h minus 1 over 2 divided by h. Fraction over, or fraction inside of a fraction, we've seen this a few times now. Our least common denominator will be 2 times 2 plus h. So multiply this side by 2 over 2, and we will get, this is the limit as h approaches 0 of 2 divided by 2 times 2 plus h. Multiply this side by 2 plus h over 2 plus h, and we'll get the same denominator, so I can just write the denominator once. We would get 1 times 2 plus h, get something like this. And then we want that whole thing over h, which I'll write as h over 1. And the reason I'll write it that way is because I can, well, 2 minus 2 plus h is 2 minus 2 is 0, and then we get the negative h divided by 2 over 2 plus h. And then I can, the way I divide fractions is by multiplying by the reciprocal of the denominator. In other words, instead of h over 1, I make that 1 over h if I change this from division to multiplication. Now these h's cancel, and I get that this is equal to the limit as h approaches 0 of negative 1 over 2 times 2 plus h. I can evaluate this limit. I can change all the h's into zeros, and I'll get negative 1 on the top, and 2 times 2 plus 0, 2 times 2, 4 on the bottom. So my final answer is negative 1/4. All right, do 2 more of those. I might have made these too long. I might make you just choose some of these. We'll see. Use the definition of the derivative again. H prime of a is equal to the limit as x approaches a of h of x, which is the square root of x, minus h of a, square root of a, divided by x minus a. So we're supposed to evaluate this limit. We can't just change all the x's into a's. It would be nice if we could, but we'd get 0 over 0. But there's a little trick, and the trick says that if you want to get rid of this x minus a in the denominator, we have to multiply both the top and the bottom by something so that we'll be left with an x minus a. And what that something is it's the square root of x plus the square root of a. Something that you shouldn't be able to recognize, but we've done enough times in class that hopefully by now you knew that was that. If you FOIL out the top here, what you're left with is just x minus a. And on the bottom, you don't have to FOIL this out. In fact, you don't want to FOIL this out because this x minus a and this x minus a cancel. And so all we're left with is the limit as x approaches a of 1 over root x plus root a. And what's kind of nice is this is a limit we can evaluate. Change all the x's into a's, and we get 1 over root a plus root a. In other words, 1 over 2 root a. Either of these are fine. This is a more simplified form. So I'll put my box around that one and call that the answer. H prime of a is this guy. Whoops. Okay, last one. Guess we'll do it in blue. Same idea, except now use the difference quotient. Fine. J prime of a is equal to j of a plus h, 1 over a plus h squared, minus j of a, 1 over a squared, all divided by h. And actually it's the limit, which I keep forgetting to write. If I'm going to be more precise, it's the limit as h approaches 0 of that thing that I just wrote. 1 over a plus h, quantity squared, minus 1 over a squared, all divided by h. Okay, fraction inside of a fraction. I better get a common denominator. I better multiply this side by a squared over a squared, and this side by a plus h squared over a plus h squared. If I do that, I get a squared divided by a squared times a plus h squared on the left. And then on the right, I'm going to multiply by a plus h squared over a plus h squared, and that will give me a plus h squared, and it'll give me the same denominator. And again, I forgot to write limit. This is the limit as h approaches 0 of this mess. Okay, hopefully when the dust settles, we'll be left with an a up on top. In fact, we will, because if you expand out a plus h squared, I'm not going to forget this time, it's the limit as h approaches 0 of, I got a squared minus a squared plus 2ah plus h squared. If you expand this all out, you get this thing. You can leave the bottom alone. But you might be able to see what's going on now. Is up top here, when I subtract this a squared and this a squared will cancel out, and I'll be left with negative 2ah plus h squared divided by this mess, a squared, a plus h squared. And then instead of thinking about it as divided by this guy, I'll multiply by 1 over h. And what's kind of nice is each term up in the numerator here has an h in it, so I can factor out an h. I'll show that step. I can factor out an h from the numerator, and I'm left with negative 2a plus h. Right, this is the same as this. And then in the denominator, I got a huge mess, but that's okay. Because the important thing was to get rid of this h, this thing that's going to 0 in the denominator here, this h. I can do that now. This h and this h cancel. And so I get the limit as h approaches 0 of, in the top I'm just left with negative 2a plus h. And in the bottom I'm left with a squared times a plus h squared. And I can evaluate this limit. I can change all the h's into zeros. If I do, on the top I'm just left with negative 2a. And on the bottom I got a squared times a plus 0, which is just a, squared. So I got a squared times a squared. I got a to the 4th power. In other words, I got negative 2 over a cubed. That right there is my derivative of this function, and that is the end of this quiz.